Hi y'all, this is the second video lesson for the week. This one's going to cover solving log equations. This is going to be a little bit more in-depth than solving exponential equations was. So I would recommend once you're done watching the video to just go ahead and try the practice problems that go with it. Okay, so let's start with something more simple, example 1. What we're going to do here is try to get the log on one side and all the numbers on the other side. So I've got this plus 2. I'm going to move that to the other side. So I'm going to subtract 2 from both sides. And I've got log base 3 of x equals 4 minus 2 is 2. Now there's two ways you can do this. You can either exponentiate both sides, which means that whatever the log base is, you would make that the base on both sides. So you would write 3 to the power of log base 3 of x equals 3 raised to the second power. So I've basically just taken both sides and given them a base of 3. You can also rewrite this into exponential form, and this becomes 3 squared equals x. Okay, so going back to the exponentiating one, I can get rid of this 3 and this log base 3 because they cancel each other out because they're inverses, and I'm left with x equals 3 squared. So see, either way that I do it, I end up getting the same kind of statement. So whichever method you like, you can use that, okay? So 3 squared is 9, so I'm going to get 9 is equal to x. Now, something that we have to do with log equations that we didn't have to do with exponential equations is checking to be sure that our solution is actually valid. The one rule here is that you can never take the log of a negative number. So whenever I substitute my answer for x back into the equation, whatever I'm taking the log of cannot be a negative number. So in this case, I'm going to be replacing my x value of 9 right here. So I'm going to have log base 3, let me erase that. I'm going to have log base 3, instead of x, I'm going to put my solution, which is 9, plus 2 equals 4. What I'm concerned about is the log portion, so this portion here. I want to be sure that whatever number in parentheses, that it's not a negative number. In this case, I've just got a positive 9, so this is a valid solution. If I had gotten like a negative 9, let's say in there, that would not be a valid solution because I would be taking the log of a negative, and we can't do that. Okay, let's move on to the second example. So this time we have a log on both sides, but the base is the same. So you can either just cancel out the log base 4 from the beginning, or the reason that you're really doing that is because you're exponentiating both sides. So I would have base 4 raised to the log base 4 of x plus 2 equals 4 raised to the log base 4 of 8. And since the base of the exponential and the base of the log are the same, you can just get rid of them. Okay, and you're going to have x plus 2 equals 8. Or from the beginning, you can just go ahead and cancel those two things out and you'll get the same thing. Okay, so from here, I'm going to subtract 2 from both sides, and I get x equals 6. So let's check that. So I've got log base 4. I'm going to be replacing my x that's here with 6. So I've got 6 plus 2 equals log base 4 of 8. The 6 plus 2 that's here, 6 plus 2 is 8. So this is saying log base 4 of 8 equals log base 4 of 8. That's a true statement because they're the same on both sides. And I'm not taking the log of any negative numbers here. So the x equals 6 is a valid solution. Okay, let's look at example 3. So now we've got logs on all sides, and we're going to have to do some condensing before we're even allowed to solve this. So notice in this problem, you have an ln. Remember that ln is the same thing as log base e. Okay, so log base e, remember e is Euler's number. It's just it's a number kind of like pi. We just gave a special name to it. Okay, but log base e is the same thing as the natural log, or ln. So I've got this minus sign in between the two. When we did the log properties last week, whenever you're condensing something and you have a minus sign there, you're going to be using the quotient rule. So this is going to become ln. This 3x plus 2 is going to go on the top of the fraction, and then the 2 is going to go on the bottom. So I'm taking 3x plus 2, putting it on the top here, and then I'm taking this 2 and I'm putting it on the bottom, and then that's using my quotient rule, equals ln of 3x. So now we have one single natural log on both sides. Since they're the same on both sides, I can go ahead and cancel them out, and I can set whatever's in parentheses equal. So I've got 3x plus 2 over 2 equals 3x. My goal here is to get x by itself. So the issue is that I've got this division by 2 on the left-hand side. If I want to undo division by 2, I'm going to do the opposite of that, which is multiplying both sides by 2. So I'm going to multiply both sides by 2. So these are going to cancel, and I'm going to get 3x plus 2 on the left-hand side, and then 3x times 2 on the right-hand side is going to get me 6x. Now I want to get all the x's on one side, so I'm going to move this 3x to the other side. I've got 2 equals 3x. Divide both sides by 3, and I've got x equals 2/3. Okay. If I check that to be sure that I don't have any negative logs, I'm just going to go through and replace this 2/3 wherever I see an x in my original equation. So this is going to become ln of 3. Instead of putting an x, I'm going to put 2/3 plus 2 minus ln of 2 equals ln of 3, and then instead of x, I'm going to put 2/3. Okay, so if I simplify, these 3's are going to cancel, and I'm going to have ln of 2 plus 2 minus ln of 2 equals ln, these 3's cancel, and I'm left with 2. Okay, so I have ln of 4 minus ln of 2 equals ln of 2. So I want to check that anything that's in parentheses here is not a negative number. None of them are negative. They're all positive inside the parentheses, so the 2/3 is my solution. Okay, let's look at number 4. This one is just on the notes. It's not on your practice problems, and it's not on your reflection questions. This is a fairly difficult problem. We just wanted to expose you to it, but we're not going to assess you over it, okay? So the first thing I'm going to do is look at any log rules that I can use to kind of simplify this down first. First thing I see is that I've got this 2 as a coefficient in front of my log base 2. I can use the power rule to move that up into the exponent. So I'm going to make this log base 2 of x squared, and then everything else is going to stay the same. Okay, now I've got this addition sign in between two logs that have the same base. I can use the product rule to multiply whatever is in parentheses on both logs. So I can multiply this x squared and the 2x squared plus 15. So I'm going to keep the log base 2 the same, and I'm going to have x squared, and I'm going to multiply that with 2x squared plus 15 equals 3. Okay, now I can either exponentiate both sides, or I can rewrite it in exponential form. So if I rewrite it in exponential form, to your little snail, this is going to become 2 raised to the 3rd power. The base, the log base 2 is the base here, and then the exponent of a 3 is the number here, equals x squared times 2x squared plus 15. Okay, let's simplify that. So 2 to the 3rd power is 2 times 2 times 2, which is 8. On this side, I'm going to distribute that x squared to both terms that are in parentheses. So this is going to be 2x raised to the 4th power plus 15x squared. Now, as I continue solving this, I need to get the 8 on the other side so I can set this equal to 0. So I'm going to subtract 8 from both sides. Okay, this kind of looks like something we can factor. The only thing that's throwing me off is that I have the 4 and the 2 here, and usually when I factor, the leading term has a degree of 2, but in this case it's 4. So I'm going to use a tool that is, if you go to calculus, is very helpful. It's just called U substitution, and we've done it in class many times before. It just means that you're going to substitute something with the letter U. So I'm going to let the letter U, I'm going to let it equal x squared. Okay, so anywhere that I see an x squared in my problem, I'm going to replace it with U. In this case, I have an x to the 4th power. X to the 4th power is equal to x squared squared, because if I multiply the 2's in the exponents, I get to 4. So x to the 4th would be the same thing as u squared, because u is equal to x squared. So this is going to be 2, instead of writing x to the 4th, I'm going to write u squared. And then I've got 15x squared. Well, x squared is equal to u, so I'm going to put plus 15u. And then minus 8. The 8 doesn't get a u because it doesn't have an x squared attached to it. Now I have something where the first term has a degree of 2. So I can go ahead and factor this like normal. So I'm going to draw my eye. At the top of the eye, I'm going to have 2 times negative 8. So I've got negative 16. And at the bottom, I'm going to have 15. So I need 2 numbers that multiply to get me to negative 16. And add or subtract to get me to 15. So I'm going to use 16 and 1, and I'm going to make the 1 negative. So 16 minus 1 is positive 15. 16 times negative 1 is negative 16. So this is going to become u plus 16 and u minus 1. I'm going to use slide and divide, and I'm going to divide both of these terms by 2. So I'm using A here. If you want to do double distribution or box method, you can do that too. I'm just going to use slide and divide. So u plus 16 over 2. 16 over 2 reduces to 8. And then here, 1/2 isn't a whole number, so I'm going to move the 2 to the front, and you're going to get 2u minus 1. Okay? So at this point, I can now use this, and I can solve for u. So I'm going to use zero product property. I'm going to set both of my factors equal to 0, and I'm going to solve them independently. So over here, I'm going to get u is equal to negative 8. Over here, I'm going to get u is equal to 1/2. Okay, so I am going to now go back, and I'm going to replace u with x squared again, because I've used u for its purpose. I've substituted, I've factored, and I've solved. I'm done with it. Now I'm going to replace it. So this is going to say x squared is equal to negative 8. This is going to say x squared is equal to 1/2. Okay, x squared equal to negative 8. To get rid of the squared, I can square root both sides. Whenever I put a square root, I have to put the plus minus in front. So notice here, I have a square root of a negative number. When I'm looking at logarithms, at least for the purpose of pre-cal now, we're not going to be looking at imaginary solutions. If I have a negative under a square root, my answer is going to have an I in it, I, the imaginary unit, equal to negative or square root of negative 1. We're not going to be looking at that, so I'm just going to cross that off, and I'm not even going to make it a valid solution. Okay. On the other side, where I've got the x squared equals 1/2, I'm going to take the square root of both sides. Okay, and I'm going to cross those off. So now my two answers are either positive square root of 1/2 or negative square root of 1/2. Going back to our original problem, if I were to put a negative number in for the x here, that would cause a problem, because then I would have 2 times log base 2 of negative square root of 1/2. I can't have that because I can't take the log of a negative number. So I'm going to cross off the solution that has the negative on it. So the negative root 1/2 isn't even going to be an answer. The only answer I'm going to take is the positive square root of 1/2, because that one isn't going to cause any problems if I go to plug it back in. So I got, this one was 1, 2 answers, this one was 3, this one was 4. Really the only valid answer that I can use here is the positive square root of 1/2. That one was just kind of a challenge problem. We're not going to give you anything that difficult in the reflection questions. Just wanted to kind of expose you to it. What you are going to see is stuff that looks more like examples 1 through 3 on here. Okay, so at this point, you should have been able to complete number 1, 2, and 3 already using that exponentials video. And then here, number 4, 5, and 6, those are all solving logs. You can do what we did in the notes to help you with that. I do want to talk about number 5 here just for a minute, because I know we didn't do anything like that. With number 5, I can rewrite this into exponential form, or you can think about exponentiating both sides. I'm going to rewrite it into exponential form. So you have 1/2 raised to the negative 2 equals 8x plus 27 raised to the 1/3 power. So if I simplify the 1/2 raised to the negative 2, I can use exponent rules. I can flip what's inside, so this becomes 2 over 1, and I can make the exponent positive. Well, 2 over 1 is just 2, squared is 4. So this becomes 4 equals the 1/3 exponent, that's the same thing as a cube root. Okay, so when I go to solve this, I really need to get rid of the cube root. So I would raise both sides to the 3rd power. And I'll let you all solve it from there. I think you can take it from there. I just wanted to show you because I didn't want you to see the fractions and get worried, okay? But all the other ones are similar to something we've done, and you should be able to solve those, okay? So get these practice problems done. Once you're done with the practice problems, you can start working on the reflection questions. Let your teacher know if you have any questions. Thanks for watching.